Problem 4, a vertical flagpole is attached to the edge of a building. So I have my building, then I have the flagpole. A man stands 400 feet from the base of the building. So we have this man, he's standing 400 feet from the base of the building. From his viewpoint, or from this point, the angle of elevation to the bottom of the flagpole. Well, here is the flagpole. The angle of elevation to the bottom, so this angle right here, is 60 degrees. And it says from that same point, the angle of elevation to the top of the flagpole, so this entire red angle, so that entire red angle is going to be 62 degrees and 50 minutes. And we have to find the height of that flagpole. So what we want to do is we want to use some trigonometry, and we want to find the height of the flagpole. So that flagpole is only in one triangle. That X is only in, I'll shade it in blue, this top skinny little triangle. So if I kind of redraw that, that's where X is. Now, do I know anything about that little blue triangle? Well, yes and no. I know that this red angle kind of goes all the way through the blue triangle, and that whole angle is 6250. Now, if I kind of imagine this bottom, the ground, kind of here, I know this bottom portion, I'll label that in black, that bottom angle, they tell you, is 60 degrees. So if the whole angle is 6250, and that bottom major portion is 60, if I subtract those, 62 degrees, 50 minutes, minus 60 degrees, I'm left with 2 degrees and 50 minutes. So I know in my blue triangle, this skinny little angle here is 2 degrees and 50 minutes. Do I know anything else about this skinny little blue triangle? This is all I know. I want to solve for X, which is opposite that skinny little angle. What I can do is I can find the length of this bottom side, because this bottom side happens to be in this right triangle right here. What I can do if I extract that bottom green triangle is this. This is a right triangle, so I can use SOHCAHTOA. I know this bottom angle is 60, and I know this is 400. So I can figure out the hypotenuse of that green triangle, which is the same as the bottom of this blue triangle. I can go and use SOHCAHTOA because I have a 90-degree angle. So here my angle is going to be 60. I know Y is the hypotenuse because it's opposite the right angle. And that 400, since I'm using angle 60, this would be opposite. So 400 would be adjacent. So here's what I know about this right triangle. I have the hypotenuse, I have the adjacent. If I write out SOHCAHTOA, this is going to be an example of cosine because I have the A and the H. So I know the cosine of an angle equals adjacent over hypotenuse. So the cosine of 60 equals 400, that's the adjacent, over the hypotenuse, which is y. So I'm going to now solve this equation for y to figure out the hypotenuse of the right triangle, which is also the bottom portion of this skinny little triangle that I need to use to solve for x. Here, since the x, or the y, is in the denominator, I'm going to use switcheroo. I'm going to bring the y to the top left, so that's y, and I'm going to bring the cosine 60 down to the bottom. So I have y equals 400 divided by the cosine of 60. So here the y turns out to be 800. So So that hypotenuse of that small triangle, which is also the same as our skinny blue triangle, that bottom side is going to be 800. So I'm going to plug that in for y in that tiny little triangle. So I want to go about solving for x, the height of the flagpole. X is in this skinny little triangle. And now in that triangle, I have this angle over here is 2 degrees 50 minutes. I know this bottom side is 800. What else do I know about that triangle? I can't use SOHCAHTOA. I only have one angle. Can I use the law of sines? Do I have a matching set? And the answer is no. I only have this side is 800 and this angle is 2 degrees 50 minutes. Can I get anything else in this triangle? And the answer is yes. Look back at the original diagram. I know in this green triangle, I had a 90-degree angle. I had a 60-degree angle. So this remaining angle of that green triangle, if I go 90 plus 60, which is 150, and then go 180 minus 150, I get 30. So this angle here is going to be 30. So if I kind of draw this straight line, that angle there is going to be 30 degrees. Well, this is a straight line. If this is 30, then 30 plus this angle of the triangle has to add up to 180. If I go 180 minus 30, I get 150. So this angle here has to be 150 because the 30 and the 150 lie on the straight line. So I know that is an angle of my triangle. I know this angle is 150. And now I know two of the three angles. I know this is 150. I know this is 2 degrees 50 minutes. So now what I'm going to do is I'm going to add up the 150 and the 2 degrees 50 minutes, and I'll subtract that from 180. So that angle turns out to be 27 degrees and 10 minutes. So now I know all three angles of that little triangle that I need to solve for x. So if I go through my checklist, SOHCAHTOA, is there a 90-degree angle? The answer is no. Law of sines. Do I have a matching set of side angles? And here the answer is yes. I do have a matching set. If I throw some letters in this triangle, here my matching set is going to be angle and side A. So here now I have a matching set, my A's. I'm going to go about solving for x, which in my diagram is the side opposite angle C. So I'm trying to find little c. So I'm going to go little c over the sine of angle C, and that equals my matching set, which were my A's. Little a over the sine of angle A. So here that's going to give me little c, which I called x, over the sine of angle C. So that's the sine of 2 degrees 50 minutes. That equals little a, so that's the 800, over the sine of angle A, which was the sine of 27 degrees and 10 minutes. So here I'm using the law of sines, so I'm going to cross multiply. X times the sine of 27 degrees 10 minutes, that equals 800 times the sine of 2 degrees 50 minutes. And here to solve for x, I'll divide both sides by the sine of 27 degrees and 10 minutes. So here to figure out that height of that flagpole, which wasn't a straight 1, 2, 3 solution, I'm going to do on my calculator 800 times the sine of 2 degrees 50 minutes over the sine of 27 degrees 10 minutes. So here the height of the flagpole is going to be 86.6 feet. A bridge is supported by triangular braces. So I kind of have a bridge and then triangles forming the base of the bridge. And if the sides of each brace measure 63, 46, and 40, the question said, find the measure of the angle opposite the 46-foot side. So here we have to find the measure of that angle. Well, I'll put letters in the triangle, and let's go through our checklist. Are we using SOHCAHTOA? Is there a 90-degree angle given to you? And the answer is no. No angles are given to you. Are we using the law of sines? Do we have a matching set of side angles? No, they don't give you any angles, so there can't be a matching set. So here we're going to use the law of cosines. Remember, the law of cosines you use if you have two sides and the angle between. That doesn't apply to us because we're not given any angles. Or if you're given three sides. Here, since we're given three sides, we're going to use the law of cosines, which allows you to find an angle. So that's going to be the cosine of angle B equals a squared plus c squared minus b squared over 2ac. Remember, the law of cosines, the angle that you use matches the side that's written last and only once. Here, sides A and C are going to be used twice. So here we're going to plug in. We're going to have the cosine of angle B, so that's going to be x. That equals a squared, so that's 40 squared, plus c squared, so that's 63 squared, minus b squared, so that's 46 squared, over 2 times a times c. 2 times 40 times 63. Here, since we're finding an angle, we're going to have to press the second button and then DMS our answer. So here the angle opposite that 46-foot side turns out to be 46 degrees and 45 minutes. We look at the seconds. If it's 30 or less, and it is, it's 18, this stays the same. On a map, Orlando is 178 millimeters due south of Niagara Falls. So at Niagara Falls, I'm going south to get to Orlando, and that's 178 millimeters. Denver, which is out west, is 273 millimeters from Orlando, and Denver is 235 millimeters from Niagara Falls. Find the angle of Denver from Orlando and the angle from Denver to Niagara Falls. So Denver to Orlando, Denver to Niagara Falls. This question is asking you for basically the angle by Denver. So if I go through my checklist, SOHCAHTOA, do I have a 90-degree angle? Here in this triangle, there's no angles. Law of sines, do I have a matching set? Well, since there's no angles, there's not going to be a matching set. Here, this is going to be another example of the law of cosines because we are given three sides. You're given the length of all three sides of this triangle. So in this triangle, which I'll call triangle DNO, I have to find angle D. So that means the cosine of D equals the other two sides, n squared plus o squared minus d squared over 2no. Remember, this angle always has to match this side, and that side is only used once. So here I'm going to have the cosine of d equals n squared, so that's going to be the side opposite Niagara Falls, so that's 273 squared, plus o squared, so that's going to be plus 235 squared, minus d squared, so minus 178 squared, over 2 times n times O. 2 times 273 times 235. Here I'm finding an angle, which means I'm going to have to press the second button and then also DMS my answer. So I'll type this directly into the calculator. So here the angle by Denver, 40 degrees and 9 minutes. Nancy shines a light from a window of a lighthouse on a cliff 250 feet above water level. So here I'm going to have the water, and then I'm going to have this side here where you have the lighthouse and a cliff, and this is going to be 250 feet above water level. Nick, 10 feet above the water level in a ship off the shore. So I have a ship, and this is where Nick is, but Nick is 10 feet off the water level. So that's going to be N. It says he finds the angle of elevation to the light is 3 degrees. So we have Nancy is up here. Nick is shining this light up, and he finds that this angle is 3 degrees. So we're going straight across. That angle is 3 degrees. That's the angle of elevation. Find the length of the line of sight, the light beam, from the ship to Nancy. So basically the question is asking you to find that x. And at first glance, when you draw your picture and your triangle, it looks like this. You have 3 degrees, you have 250 degrees, and you have x. But the problem is, Nick is 10 feet above the water level. So this 10 is part of this 250, which means this side of the triangle, which I'll put in red right here, is not actually 250, but it's 250 minus 10, or 240. This distance is 240. That distance is 10, making the whole thing 250. So in my triangle, this side is 240. And that's the challenging part about this question. Once you have that 240, you go through your checklist. Is this SOHCAHTOA? Do you have a 90-degree angle? And the answer is yes. This water and this cliff, that's 90 degrees. So here I'm going to go, the angle is going to be 3 degrees. The hypotenuse is x. That's always opposite the right angle. And since I'm using 3 degrees as my angle, 240 is going to be opposite. So this is going to be an example of hypotenuse and opposite, or sine. The sine of an angle equals opposite over hypotenuse. So here the sine of our angle, the sine of 3, that equals the opposite, which is 240, over the hypotenuse, which is x. So now I'm going to go about solving this for x. Since x is in the denominator, I'm going to use that switcheroo rule, where I'm going to take the x and the sine of 3 and switch places. So here I'm now going to have x on the left. That equals 240 over the sine of 3. So if you do 240 over the sine of 3, you'll get the value of x, which is that distance from, basically from Nick to Nancy. So here you get 4,585.8. Problem 10, Yogi Bear is walking with Boo Boo looking for a picnic basket, and they sight a beehive up a tree. So here we're going to have our tree. We'll have the beehive at the top of the tree, and it says the angle of elevation. So they're going to be walking towards this tree. So they're going to be walking in this direction. and it says from this point, they spot this beehive, and the angle of elevation is 36 degrees. They walk 120 meters closer. So we have our tree. They start off here, they have this angle. Now they're walking 120 meters closer. So this distance here is 120 degrees. And they find now from this new point, the angle of elevation is 51 degrees. How far are Yogi and Boo Boo from the bottom of the tree from their current spot? So here they're asking you to find this distance, because they started off back over here with the 36-degree angle. They walked to this point, which is now the 51-degree angle, and they want to know how far from the tree are they. And here, in order to figure that distance out, that x is only in this right small triangle right here. So that's the triangle that I ultimately want to use to go about solving for x. What do I know about this triangle? I know that there's a 51-degree angle. Other than that, I really don't know too much. What I'm going to do is I'm going to have to use another triangle to try to figure out stuff about this red triangle that I need. If you look at this big picture, here you know this angle is 51, so the angle next to it, since they lie on a straight line, has to be 180 minus 51, or 129. So I know that angle is 129. In this triangle that's adjacent to the red one, you know then two of the angles. You know this angle is 36, this angle is 129. I can find this top angle by going 36 plus 129 and subtracting that from 180. So that's going to be 165 take away from 180, or 15. So I know this angle is 15 degrees. Now what am I trying to do? I'm trying to get more information about my red triangle. Once I know something else about this red triangle, I'll be able to go about solving for x in the red triangle by using SOHCAHTOA, since it's a right triangle. So what I'm going to do is I'm going to go about finding the hypotenuse of that red triangle. The hypotenuse of the red triangle, this side here that's in black, this is also a side of the blue triangle. So I'm going to find that first. Maybe I'll call this side y. Let me separate that blue triangle. I want to find y, which is also a side of the right triangle. Well, now I know a lot about that blue triangle. I know all three angles, 129, 36, and 15. And I know this 120. So I can go about solving for y in this blue triangle by using the law of sines, because I have a matching set. So if I put some letters down here, I want to find y, which happens to now be opposite my 36-degree angle, which I called a. So I'm going to go a over the sine of a. That equals, now my matching set are my b's. So that's going to be b over the sine of b. So I'm going to go about finding this y, this side of that obtuse triangle, because that's also the hypotenuse of the red triangle, and that's what I need to go about solving for this x. So here I'm going to have a, which I called y, over the sine of angle a, so the sine of 36. That equals little b, which is 120, over the sine of angle b, so the sine of 15 degrees. So here I'm going to go about using the law of sines. So I'm going to cross multiply. Y times the sine of 15. That equals 120 times the sine of 36. So here to get that y, that side of that blue triangle, which is also the hypotenuse of my red triangle, I'm going to do on my calculator 120 times the sine of 36 over the sine of 15. So here I have y is equal to 272.5. Well, that's going to be that side of that blue triangle, but more importantly, that's also going to be the hypotenuse of that red triangle. So I'm going to label the hypotenuse now as 272.5. And now I'm going to go about solving for x. Here I'm using SOHCAHTOA because it's a right triangle. My hypotenuse is that 272.5. Here the angle is going to be 51. And, well, opposite would be the height of that tree, but that's not what the question is asking me for. The question is asking me for x, which is going to be the adjacent. So here, if I'm using SOHCAHTOA because I have a right triangle, I have the adjacent and the hypotenuse, so this is going to be cosine. The cosine of an angle equals adjacent over hypotenuse. So the cosine of the angle, here the angle is 51, that equals the adjacent, which we said was x, over the hypotenuse, which was that 272.5 value. Here I'm going to put the cosine of 51 over 1 and cross multiply. I'm not using switcheroo because x is in the numerator, so I'm just going to cross multiply. 1 times x, which is x, that equals 272.5 times the cosine of 51. So how far are those two from the base of the tree at that second point? I'm going to do 272.5 times the cosine of 51. So here they're going to be 171.5.